Friday, man.
Is it Friday? Are we taking the day easy today?
I think that's a good idea.
This isn't that bad. We're gonna get through this stuff. I want to get through product rule and quotient rule before the end of the week. So we'll get through it. It's not bad.
Are we doing the questions after?
Yeah.
4 point. Not great.
So this is 4.7 in the textbook. It's the quotient rule.
Did you handle questions yesterday?
Yeah, 1 to 15. So with the quotient rule,
What page is that? Do you know?
it's right there. Flip it over. Like 191 or something.
Oh, right. Yeah, 191.
Okay. So with the quotient rule, yesterday we were doing, derivatives when we had two things being multiplied. The quotient rule is when you have things being divided. Okay. The quotient rule. So we'll go with our big F function again. And you have something where you have one function being divided by a second function. The quotient rule, this guy here. Okay, it's second times first. Oh, derivative first
Get your back straight.
times the second.
Is it Friday?
Now with product rule, we added with the quotient rule, we subtract. Subtract the original function of the first times the derivative of the second. Now here is plot twist.
No.
It's not that bad. You just take the second function and you square it. I don't know why, it's just what it is and it works. I'm not going to do the proof, like there's a proof that I could do that uses like the definition of a limit. Yeah, so.
I got a real question for you.
Yeah. If you guys want a short-handed term for it, like another way we write this is to go F prime times G minus F times G prime.
Okay, question for you.
Yeah.
If you go F prime times G prime minus F prime times G prime, shouldn't you get 0?
No, this is the derivative times the second minus the first times the derivative of the second. So the derivative is not the same as the original function, right? G and G prime are not the same thing. It's a good question, actually.
Sure.
Yeah, what's up? Just pause the video. Okay, so it's just like before, okay? So I'll do some examples and we'll go from there. Yeah, this is a fun one. F of x equals 6x squared minus x minus 15. Most people generally like quotient rule better because after doing product rule for a day, you remember how to do derivatives a lot easier. So it goes by a lot quicker. So F prime of this one. So you take the derivative of the first. Okay, let's get them backwards. Derivative of the first times the original function of the bottom one.
Wait. So long. Never mind.
You didn't watch the video yesterday, did you?
No. Last unit, we weren't allowed to do the 2 times 6 equals 12, right? In limits.
Oh, yeah, that was for limits. Now you can.
Yeah.
I'm not. We're not going to put it all to f of x plus h and then take the derivative as an approach. H approach here. No. Now we can use the easy formula. Okay. Now you take the original of the first. Times the derivative of the second. Okay, now, with these again, we'll work on the algebra. You guys said you wanted to break it all the way down, right? That's kind of what we agreed upon? Yeah, okay. So I'm going to do my FOIL here. I'll do this here. I'm not going to touch the top just yet. Or the bottom, sorry. Whatever, man.
What?
Yes.
Just making
Friday.
sounds. Stop.
That's not even English, man.
Oh my gosh. I'm supposed to be my teacher.
Yeah, I'm teaching.
Stop doing this.
36 equal to. Now, the only reason I'm not expanding out the bottom part is because if you multiplied it out, then you're going to have this long polynomial. This is actually, it factored. It's done already. It's nice and neat. Leave it alone. Okay? There's no sense doing FOIL on this big thing and then trying to simplify it because you'll just get this again. Okay? So now we'll start combining some like terms. 24 taken by 12 is 12x squared. Negative 34 plus 2 is 32. 30. Take away 3 is 7. All right. Now, we'll just keep going. We can take a 3 out of everything here.
It doesn't
Oh,
work.
wait a minute. I must have messed up.
Isn't there a minus 2x in the positive?
It would be negative, positive. This has to be positive 32. It's 12.
Oh,
Should be 36, and then it should be divisible by 3.
Yeah. 12 times 3 is 36. Take away 2 is, oh, it's positive. There we go.
Yeah, so it should be 36, right?
That's an easy fix. You're all okay with that.
I'd just like to state I corrected Mr. Weber.
I caught it. Yeah. No, whatever. All right.
Me and Mackenzie caught Ms. Weber.
All right.
You
guys-
didn't know.
All right. And it's on record.
it doesn't count when you're dick about it.
Hey, I was just throwing. Hey, that's like my first point. Give me it. Give me a break.
No.
All right. So 36. So it's plus 12x. Now I can factor this down.
Oh my god.
This one's going to work out quite nice. 4x is 2x times 2x. Right, 2 brackets.
Oh. Is it gonna be the bottom?
Spoiler alert. They're both the same.
Oh my gosh, how did I guess that? And then they cancel out and make a 0.
Not 0.
Oh, no, it is.
First one cancels that one out.
So that's 3. Over 1. Usually. Oh.
Okay, I'm not impressed that we did this. You know what I'm impressed with? Somebody took the time to figure out if you did all the derivative work of this, you could work it out
3.
to get a nice 3. Like that, like the writer of this textbook is just,
Just gonna do it all backwards.
No, because like the antiderivative of this would just be 3x, right?
Oh,
You would have to
oh
like
God.
know that you would have to know that you wanted this as your answer to get rid of this, and then expand that out to get this, and then multiply 3 together to get that. You would have to work backwards, I think.
Yeah.
And then I don't even know, like, yeah, then the math. Forget it.
So someone, oh my gosh, I guess this is not just like magic. Like,
No, like, remember every time I would make up a question and it would work out not working out? You know?
Why don't you do this? Pull some magic out of this.
If you could write a textbook, bang. It's huge.
You make bank.
Oh, yeah.
Why don't you make a textbook?
I can't do that.
Well, when you drop your thing, you go, I'm the
Yeah,
best.
I can solve them. I can't create them, though.
You're a wizard.
But to create them, shouldn't you have to be able to solve
No. You just have to know what numbers
Yeah,
go together.
to create them, you should be able to solve them. But to solve them doesn't mean you have to be able to know how to create them. All right, let's try another one. This one won't be so bad.
Never
Oh,
gonna
that
happen.
hurt.
All right, on a scale of 1 to 10, how are we feeling so far with this stuff?
Okay.
Okay? Good.
Solid.
7.
Okay.
Like, if I wrote a test right now, I'd get a 7.
7%.
D%.
People generally like derivatives.
It's
It gets easier. It's repetitive after a while. It's not bad.
What's like the units that we have left? Or is this it?
No, there's like then we do some application stuff.
Okay.
Like there's graphing, so you learn how to graph a function using the derivative. We get into some application word problem stuff. That's probably the hard stuff.
Hopefully.
The word problems.
Oh.
Is that a YTV T-shirt?
Yeah.
Oh my gosh.
Got it for Christmas.
That's old.
Yeah.
And then we get into some other derivatives like sine and cosine, log and stuff. Yeah, it's not that bad though.
So
It's all like this is the derivative of sum, so you just do that every time. So it's not bad. All right, so we want to take the derivative of this guy. So dy over dx. So derivative of the first one, just 2. Times the second. Minus the first. Times the derivative of the second. All over. Yeah, and I rarely expand out the bottom. Okay.
Do you ever?
There will be instances where you have to, yeah, but typically, most of the time you don't have to. I leave that to the end as a last resort. Okay, but like this stuff, you can do all this. 6x times 4 times 6x. Good.
why is it 5? Oh, that's positive 9?
Yeah. Negative and a negative.
Wait, what?
So the negative and the negative.
That's positive.
No, wait.
Like right here is multiple of negative.
Yeah, but then this negative sound.
Fine, be like that.
Okay.
That was in my glasses.
Let's do
Please pick it up.
one more.
Scary. Explain that.
Mr. Weber,
What?
Yes.
I mean, yes, Carson, how can I help you?
what are we doing in bio today?
Active transport. No, you can't have a free class.
I have a proposal.
No free class.
I have a proposal. When's our next SDS birthday?
Workday? Not till sometime after the
I
things
also
come in.
need an SDS proposal. 'Cause I don't-
You weren't here for that? Oh yeah, that's good to know. Been here with.
Does that say biology 30 on it?
Yep.
You promise? Help us in depth.
Alright,
Did you start the recording?
no,
Okay, good.
that's all there. Alright, so, let's take the derivative of this
Wait,
one.
you did or you didn't?
I didn't stop it.
It's recording.
Oh
right
boy. Wait, is this the same one?
This is a new
This
one.
is a different one.
Oh boy.
Let's go to square root.
So remember, square roots are written like this.
How many more examples are we doing?
Illegal.
Last one.
Yeah, square roots are illegal.
So we take the derivative of the first one. Do you guys want to see the derivative of? So if you take the derivative of x to a half, you bring the 1/2 down, you minus 1 from this,
Negative a half.
right? So
That's so stupid.
what's wrong with that? Does that make sense why I got that?
Yeah.
Yeah, it's just stupid.
This is
I
stupid.
don't think I-
You have root x and just moved it to the bottom.
So to make this positive, remember you got to bring it to the bottom.
So how do you get rid of square root?
Well, this is like the square root of anything. Remember, it's always the 2's implied. So like that. Okay.
It's like the last question.
Okay. Give me 5 minutes. Okay.
Yeah.
Read over the rest of your test. Make sure you're good.
Yeah.
And then-
Cool.
Okay. So that's the square root. So that's the derivative for a half. Okay.
Okay.
So this just becomes like that. Okay. Times the original function. Can I erase this stuff over here?
Yeah.
Okay, sure.
That's what your heart desires.
Minus now the original times the derivative of the second. All over. Okay. So what do we do now?
Cry.
I would normally leave it like I would. Okay, good. But the textbook won't. So this would be like a hard question. Okay. This is a 5 out of 5. I'd say on the hard scale. Okay.
5 out of 5.
5 out of 5. So according to this,
Diamond level.
so
Dense.
what they do? Oh, they did it differently.
Let's just
Cut
leave
diamonds.
it. I think we should just leave it.
Yeah. If we for a hard question like that.
What?
I'm gonna put it in this here.
What the textbook
No,
did
you're not.
is what they did is they rewrote it. This is how I like my this is how I like my derivative of a root. I like it written like this. The textbook wrote it like this.
No.
How funny would that be? You'll be like, oh.
I like that more.
You like this one better?
Yes.
Okay, we'll go with that.
Get detention.
Yeah, fully.
Okay, I'm just gonna
Oh,
rewrite.
could you get maybe?
Does that really make it better?
Yeah.
Okay. Okay. Sorry, we'll leave it like this then. The group is spoken.
I speak on behalf of you.
All right. So what we'll do now is we'll do our distribution.
You know, bald. Mr. Barber, don't look that way.
Carson,
Look at this one first.
don't start.
So what?
Don't do anything you're gonna regret.
Will I regret it though?
Yeah, you will.
Okay. So I do my distribution. A half times 2 is just 1. Do you guys remember what to do when you multiply? What do you do with the exponents?
Yeah. Adam.
You add them. So negative a half plus 1 would just become
Aha.
a half. And then this guy times 1 would just be that. Well, let's do this then. Then the 2 root x becomes.
Why are we doing so many halves?
Remember all those times I said get used to fractions? You gotta get used to fractions, get used to fractions.
And you're like, no, Mr. Webber, we hate fractions.
Yeah. Now these worlds are colliding.
Now you're like, I'm God. I can solve anything, but I can't.
Right. So I can combine these terms here.
I can think it in my head.
1 take away 2 is negative 1. So I'm going to go 1 half x negative a half. Is it too much?
Yes.
I can go back to the black.
Yeah.
Okay.
1/2 x black. 1/2 x, half black, half white. I don't know. Can you write it in white?
What would be negative 1? Now this is probably where the textbook leaves it. Oh no, of course not.
That answer's like 4.
Holy guacamole.
Oh boy.
We'll leave it here. I'd call that good. What they end up doing is they take a common factor out of everything,
Oh yeah.
and they can make these the same. And
Why
yeah,
don't, why don't we do that?
you want to do that?
No.
We can go as far with this as you guys
Yeah, let's
want.
keep going.
Are we gonna have to keep going if you give us a question like that?
No.
Okay, well then let's not bother.
Okay. This is like where I would call it good. Okay.
How
Yeah.
many units are there in this?
There's 9.
I'm not even half done. We're legit half done.
Okay. So for you guys to work on, I'll be right there with them. Just on page 195.